Hey everyone, so today I'm going to be talking about Socket.io as a chat and general event platform. So getting to it, what we're going to cover is we're going to cover what WebSockets are, what Socket.io is. We're going to go over Socket.io on a Node.js backend. We're going to go over Socket.io on an Android client, and then there's going to be a demo and the next little summary. So what are WebSockets? So typically, in any web application, client-server liaisons are kind of request-response based. The client initiates a request, the server opens a connection, the server writes out the response, the client receives that response, and that connection is closed and terminated. And this isn't efficient for requests that require multiple round trips to have useful information, or resources that change frequently and access very much, because for each of these requests, you create a new connection, that connection is terminated, T support is terminated, and you just go through, and if you're using like a Java server, you just have multiple thread pools just creating and terminating requests and so on. It's also about the things that best modeled as streams that are just frequent short bytes of really small data. And there are ways around this regular limitations, which typically are just a limitation to HTTP, because most web applications are built with HTTP. You can use GraphQL to solve the multiple round trip server. You request what you want, get what you need in one trip. Or HTTP2, which is relatively new, for the server being able to push data to the client. So you have the client initiate a TCP connection, and instead of just writing out the response once, you can write the response, and that connection is still kept open, and the server can still keep pushing data to it multiple times. So you can have this nice abstraction with parallel streams and so on and so forth, which is great. However, these solutions are good. They're only pertinent for solving problems in their own domain. If GraphQL is great for a bunch of applications, isn't great for all. There are a lot of applications that are really best modeled as resources with REST, and then you go to that endpoint for that resource, and so on and so forth. It also isn't great for streams of data, right? Even though HTTP2 does have streams, your stream is still tied to the specific request you made for it. If you haven't requested for information on a certain path, you won't get a stream for it, right? So you're still tied to this, request response type thing. And both of this also like the piggyback of HTTP, right? So you still need to create an HTTP request that both built off HTTP1. Even if it's HTTP2, they still, are tied to HTTP. Now, WebSockets come to the rescue. What is a WebSocket? This is lifted from Wikipedia because it's succinct and it says everything that is pertinent to what a WebSocket is. It is a computer communications protocol providing full duplex communication channels over a single TCP connection, meaning that you have a single TCP connection and anyone can send information at any time and the client will receive it. Now, how do you actually open a WebSocket? So the WebSocket specification, it actually starts out with a typical HTTP request. You send a request, and in the request, you mention that you would like this connection to be upgraded from HTTP to WebSocket. And then when you do that request, if you're using HTTPS, there's a handshake, and then boom, your request is upgraded to the protocol, as long as the client supports it. Now, what is Socket.io, right? Because we've been talking about WebSockets so far. Socket.io is actually an API wrapper around WebSockets. And it's really great because regardless of whether you're using Socket.io, whether you're using it on the server or you're using it on the client, its API is extremely similar. And it's very simple. There aren't that many things to learn about it. It is rather robust, and if it is unable to upgrade the connection to a WebSocket connection, it will fall back to long polling over HTTP. Which isn't ideal, but if you're using Socket API, Socket.io, you don't have to worry about your client supporting WebSockets. It will fall back to HTTP long polling. However, it is not equivalent to WebSockets. It's its own thing. It just uses WebSockets as an implementation. Theoretically, you can wrap around any other transport protocol and still work fine, in the case where the socket isn't available and it falls back to HTTP long polling. And it is not a replacement for HTTP or REST. Socket.io is best used for WebSocket-y, and you can create your own protocol or thing how you'd like to communicate with your server for it, but it's not, because a lot of things that HTTP and REST do very well, and WebSockets doesn't have implementations for those things that's standardized because it's not meant for those things. So let's talk about Socket.io on a Node.js backend. Now, there's some things that you need to know if you wanted to use Socket.io for a Node.js backend. You need to know what namespaces are. Namespaces are similar to URLs or endpoints in a typical REST application. You go to a particular namespace for a specific, resource on that socket. And there are adapters. Adapters are nice little plugins that let you add. It makes your WebSocket pretty much extensible. For example, a common adapter you may want to use is a Redis adapter, and what that adapter is great for is if you have, like in our case, where we have ephemeral servers, because the WebSocket is opened on the server, if I was using that WebSocket and I needed to talk to UGit, for example, and you're on server A and I'm connected to server B, you would need some synchronization mechanism to make sure that what I sent to server A still is broadcast to server B, so it doesn't matter what socket or what server it's running on, everybody still gets the same message. So that's what adapters are great for. And then events. When on a socket, with Socket.io, you get events, typically in the syntax on. So on event, do this. So when there's an event for whatever type, your socket will broadcast it to whoever is listening, and that's how you process your events. And there are acknowledgements. Now, when there's, if you receive a request on a server, when you want to write out to your client, you acknowledge it, and that'll push data back out to your client. And like REST, socket connections are stateless, so it's up to you to come up with a way to persist state in your Socket.io application. With REST, typically you use cookies, or you could use JWT tokens like we do here, or you could use a session. It's entirely up to you, but you do have to, if you need state preserved in between sockets, like especially for authentication, you need to provide that yourself. A couple of years ago, I learned that I was working with some Apache Java server, and I learned that your session is not the best place to put stuff, but it's an extremely convenient place to put things. So when I build things in Socket.io, I tend to do this. I just take all my state, just shove it in the session, because it's convenient. So let's look at an example. This is a web app I built a couple years back. It's an app, it's a team management app, and then it uses sockets for the chat implementation. So you notice that there's this entire file, socket.js, is a really small, succinct file. This entire file is implementation for real-time chat. You notice there's a team chat namespace, and then the events I'm interested in. You can connect, you can disconnect, you can join a chat, you can get a new message, and there's an error. So typically what happens is, so you notice that the movie.exports is just requires Socket.io, you pass in your server. In this case, it could be an Express server, it could be, whatever kind of server you have running on Node, and then you require the socket, and then you just invoke that the function that Socket.io returns for your server. And this is why I configure the Redis adapter. And then I tell it I'm using this Redis as some URI provisioned by my config, and then the DB, the Redis DB for it. And then I have this IO events IO. Remember when I said to create a socket connection, you first start with an HTTP request? Because I'm just taking things and just shoving in the session. When I want to authenticate someone connecting to my socket, I would like to retrieve their session. And if their session doesn't exist, then they're not logged in. So what this does is getSession is just a method that grabs the socket, checks the handshake, and returns the session if it's present. Then you can also get my user ID from your session, and then there's log error. And then you can just see that to check if the user is logged in, you just grab the session from the handshake. And if there's no session, and I use password for authentication, if there's no session and there's no passport, then the user simply isn't logged in. And then this is the bulk of it. You have this IO events that we call, is a function that just listens to every event that you're interested in on the socket. So I have a team chat namespace, it uses the IO session, and then on event. So this is on every connection event. Every connection event will give you the socket that your client is connected to, right? So as a server, every time there's a connection, you're connected to a certain socket. Now, if I, as a client, wanted to join the socket, I will need to call from the client side, join, I'll create my socket, invoke it on the team chat namespace, attempt to join the chat, and to join the chat, I'll need to have provided args for my team. So I first grab the team, and then, this is Mongoose with Mongo. Try to find the team by that ID. If that team doesn't exist, the server just kicks you, the socket just kicks you out because you're not authenticated on that server. If that team doesn't exist, or if you're not logged in, like in other words, you didn't pass the proper cookie information to identify your session, it'll also kick you out. Then it queries, it finds your role on the team, and then it grabs your session, and then this is the important part because it doesn't matter what device I want to use to join this chat. I should be able to pick the chat up on this phone, on that phone, on whichever phone I'm signed into. What it actually does is that every time you create a socket, you're valid on that socket. It will go into your session, and then there's this key value pair that stores your role and the team that you're trying to chat on. So every time you go back into that, it could be a brand new socket, but it's saved in your session. Every time you connect to the client, to the server, it knows who you are, and this is how it persists little. And there's not much information on it. It just keeps your role. And the only thing you really need to roll for is to send out your image. So whenever you send a chat, it just says this chat was sent by this person, and this is a profile picture for the user. And this is how you connect to the server. And then every time you're connected to the server, and I send a message to the server, in this case it's a chat, the on-you message will be called, and then it's that every time I send a message, there's a team chat, and there's an acknowledgement. So again, you do the same things. Are you logged in? If not, go away. If there's a valid session, use it, otherwise go away. And grab the chat session, which is what is serialized in the session. And then it just does the write to the chat database with Mongoose, save it. And once you have that saved chat, what it does is it serializes it, gets the user to JSON, gets the user's image URL, which is entirely why we're using sessions in the first place. And then this is notice that I am invoking acknowledgement. So acknowledgement here is a function. When I acknowledge that I have received that chat, that writes out to the client that hey, I received this, it's all valid, and then the client will continue processing it. So you then, once you acknowledge it, you say socket.broadcast to the namespace in which you joined on, that someone has emitted, there's a new message. And everyone connected to that team will get that message. And this is for, this is just push notification. So this is what actually just pushes the single Firebase notification onto the device. And that's it. So the entirety of the server side for using Socket.io to chat is this one JavaScript file. Now, you can have multiple namespaces. You can think of namespaces as kind of like, rooms in Slack, because those are namespaces. So if you wanted to, create namespaces for individual communications, you could also do that. Or if you wanted, you could also just use the same namespace but retrieve a different entity from the database. Because ultimately, when you emit, you're going to emit to a room. And you notice in this, after you acknowledge it, on a new message, you take the socket and you broadcast it to the room. You broadcast it to the room ID. So if you wish, you could use the same namespace for everything. In my application, there's only one namespace, and that works fine. But you could create different namespaces for different events. Think of them as endpoints, and the only endpoint for this particular socket is for team chat. You could use one, in our case, if we wanted to say, because Sabertooth could lend itself very well, because Sabertooth generates lots of events. You could imagine a situation where there's a socket, and then if you wanted to process into update scorekeeping, instead of calling an endpoint, you would just open a socket and send a broadcast of the event, engaged in the event, and then it would just process it, right? And it lends itself very well to reactive programming because there's no response, there's no request, there's no response. It's just a stream of data and just write it out to the socket. Socket.io also supports things, Socket.io ultimately writes bytes. In this case, I'm just writing JSON. You could, if you wanted to write binary data like images, you just write anything you want to the server and you get it back. Okay, so that's what Socket.io looks like on a Node.js backend. Now, what is Socket.io like on an Android client, right? So again, Socket.io is great because of how portable it is. The API surface is pretty much identical whether you're using it on the server side or client side. You still have the notion of namespaces. You still have the notion of events. You still have the notion of acknowledgements. The difference with acknowledgements is the server acknowledges requests. the client doesn't acknowledge them, it just receives that this has been acknowledged. So that's just the mirror between and Go. Unlike REST, you need to provide your own way of authenticating users to applications when they attempt to join your namespace. And again, we'll just go through a quick example of what this looks like. Okay, also something I forgot to mention for the server. This is just a JavaScript file that you invoke it with your server, and then it just listens for I/O events in that socket. The way you actually connect it to your Node.js application is, so here I have an app, required server.app. This will return my Express application. Then you have the SSL, and then you create the socket, which is just an invocation of the previous socket file. And then after you normalize your ports and everything, and you create your server with the SSL options you passed into your Express app, you'll just invoke that server from the socket IO socket function that returns, that will call the IO events and pretty much let you listen to all common requests on your server. On Android land, again, it's a fairly short file. There isn't much going on there. So again, you notice that I have references for my cookie, I have references for my team chat namespace, I have the event for when a new message happens, I also have an event for when I attempt to join. So this is just a fact sheet that creates sockets every time you want to chat, because Android being a mobile application is resource constrained. You do not want to leave the socket listening whenever you're not using it. So every time you navigate to the chat screen, it'll open the socket. Every time you leave, it'll close the socket. And the sockets are fairly cheap to create. I remember again, like I said, the sockets do depend on HTTP to initiate the request. So the first thing you'd want to do is, and again, because you do have to provide your own way of authenticating your users for your socket application, you notice that when you want to build a socket, the first thing it does is it grabs the OK HTTP client that is already used for regular REST requests on the app. So if you have some HTTP client that you're already using for REST, you need to grab a reference to it. Once you grab a reference to it, you tell it that, okay, for my HTTP call factory for the thing that I'm going to use to initially create that request, just use the regular client that I use for my REST request. And then after you do that, you then specify the options that you want for your socket. You say whether it's secure. In this case, it is. Do you want it to reconnect? No, because in this case, sockets are cheap. If there's an error with it, rather than attempt to reconnect, it's easier to just grab a new instance because you don't know when that will error down. And then you can also choose your transports. So initially, like I said, Socket.io is an API that wraps other communication APIs. You can use WebSockets, you can do long polling. I found in my usages that if you let it fall back to long polling, it's a little too eager. If you're trying to initiate the connection, as you're trying to upgrade it to a WebSocket, it's just a little too eager to I know the socket is in there, I'm gonna fall back to long polling. So you can tell don't do that. Just the only way I want you to communicate is with the WebSocket, and that's what this does. And then you give it your reconnection attempts and so on and so forth. Now, every time you build the socket, every time you create the socket and you attempt to connect to it, there's because the bunch of events that you can latch onto, again, because I need to pass my cookie ID into the socket as I try to connect to it to authenticate myself, what I do is there's a route header events thing on the client, and what I do is you get your cookie, and then you just add it along with the headers in the HTTP request that is going to authenticate on the server. And as soon as you put that cookie in, this is what the server is going to take with the HTTP handshake and figure out if your session is valid or not. So you do have to run that header request into it. And that's pretty much the entirety of creating the socket. The socket is, it uses RxJava. You create a socket, there's an atomic reference globally for the current socket. You grab it, if it's connected, just return it, otherwise it just delays about a second, 1.2 seconds, maps it, checks if it's connected, and it should be connected at this time. If it's not, it will just keep on. It doesn't use exponential backup because you're trying to chat, but it will keep doing this until it fails a number of times when there isn't an internet connection. But you go back to the screen and try to pick it back up. So that's how you'd actually create the socket on the client. How do you actually use the socket though? So this also uses the repository interface for architecture. So there's a chat repository. It's got an API, it's got chat.io. But if you actually wanted to listen for chats, right? You've created your socket. You want to listen for people actually sending messages to you. You just get that socket factory I just went through, get the socket, and then you start listening for it. So you just return a full emitter, and then every time there's a new message event on the socket, you just say there's been a new chat. And once there's an error, it just terminates, right? So this just uses RxJava and just takes the socket, and because sockets by definition are event-based, it's very easy to take a socket and plug it into a publisher interface via RxJava. And that's for listening for a chat. If you wanted to post a chat, this is a completable, you grab that same socket factory instance, and then you create a completable, and then you try to create your JSON object that represents your chat. You grab your socket, you tell your socket to emit it. Once you emit it, once the server calls the acknowledgement, you do get it back. So once the server acknowledges it, that's where args comes in, and then this is a chat that was created as a server, which should be identical to the chat you passed in. Once that's done, you update it, and the emitter is done. You have posted a chat, and this is how you pretty much create a Socket.io application for chatting, right? So we've spoken about figure out what.
It's the full screen.
Is it? Thank you. So again, namespace is identical. There are events, there are acknowledgements, and like REST, you need to provide your own way of authenticating users for your application when they attempt to join your namespace. So let's look at a demo. What does this actually look like? I'm gonna here. So I've got my personal phone here, the Pixel 3, and then I've got my Android emulator. So I'm just gonna show this prior. So I'm in this chapter, right? So pretty much the same thing I was talking about. As soon as I get into this screen, it's going to go call that factory for creating sockets. I'm actually have a socket right now. And I'm just going to say, hello, this is from and then it comes back over there. And the same thing goes, like it, and that will also it also call the socket over here, back over here. And it also the same thing goes for the push notifications as well, right? Because Google gives a nice Node API wrapper for Firebase. If I leave, I could type crap again, and then I've got the push notification for it. That's what I said. It's on this chat with me. And that's pretty much it. And also, the server, if you were curious what the server infrastructure looked like, this is Google Cloud Compute Engine. So this is going to be identical to AWS's ASGs. Google Cloud calls them groups. And then this is the Redis VM. In this case, I think there's should be only one instance of the server running right now. Yeah, it's just that one. But if there were multiple instances, it wouldn't matter because everything is synchronized externally with this Redis VM. So so regardless of how many servers you go through, like I was talking about in the server configuration, there's an adapter that will sync everything with Redis for you. So it doesn't matter how many of these you spin up. Everything just will go through Redis and everything is synchronized. And that's it. That is what Socket.io is. It's a very nice wrapper around asynchronous or streamed events that is built on top of WebSockets. It will fall back to long pull and sockets aren't available. If you wanted, you could come up with your own implementation to support it that are not WebSockets or HTTP. And yeah, that's pretty much it. Yeah, that's Socket.io server. Yeah, no, sure.
So in your application that you built, did you have like server side persistence of the messaging?
Yes. So I'll just run through this real quick. So on the IO events IO, so there's a namespace, and then on connection to that socket, once you've joined the chat, you'll try to find your team, find your role in the team, save that to your session. So now you've joined that thing. If you wanted, you could send an event that said the person has joined the chat. This one's a bit silent, but you could if you wanted. And then as soon as you actually send a message to it, just to check again, are they logged in? Check for the session, check for the chat session that says their role and who they are in the team. And then this is a Mongoose ODM call that will actually persist it. And then as soon as it persists it, this is what sends out the Firebase notification. It's called a view controller. I wasn't going to think of a better name. It was supposed to be a feed. And then this is what actually notifies everyone with the Firebase command. But this actually does write it. So it saves it, writes it, and after it writes it, it acknowledges it. So there's the acknowledgement function that is passed in from Socket.io. It acknowledges it that this is, you wrote some chat in, I've saved it, this is what I've actually saved, and here is me acknowledging.
So if your phone is offline,
yeah.
And you can't receive the Firebase messages,
yeah.
when you log in, can you fetch all the messages that you missed while you were offline?
Yes.
Yes.
Yes. And then I think Firebase also does the thing that you still get your notification regardless if your phone was turned off. I mean, we could try it. So I'm gonna close this. I'm gonna turn my Pixel off. And then I'm just gonna write out, this is a test for when the Pixel is off. Yay! Okay, and then I'm gonna turn the Pixel back on. Alright. I'm using Android Q beta, so it's probably gonna take like maybe a minute and a half or something.
The answer to other questions.
Meantime question. What kind of like scaling concerns are there in terms of like if you have a bunch of people connecting, like number of threads or what are your limitations on resources and like as opposed to like what are their benefits as opposed to HTTP and that?
So ideally it shouldn't ever happen because the servers are spun up by Google Cloud Platform, and it's packed to an instance group that would automatically scale. And then everything's behind Google's load balancer. So no matter how many servers I spin up, everything should be fine because I still have Redis as the external synchronization mechanism, and that is its own server, and that Redis compute engine server, that's the only thing it has to deal with, synchronizing, right? So you can spin up as many ephemeral servers as you want. Everything is synchronized externally to Redis, and it should be fine. I haven't tested it yet because I never got that many users. But when Google builds it, you have the scale of Google, so I'll take that word for it. Oh, this is back up.
And if you need one server to do it, Elixir or Phoenix, you can get up to 2 million concurrent on one server.
What about HTTP though?
Just Just trying to bring up the screen back. So it's back up, and yeah, so I've got 3 new chats from Titans. This is still there because I hadn't read it before. This is the test for when the pixel is off, and yay! So everything is back there. Click into the notification, and it came from this guy, and everything is there. So yeah, those persisted, but that's a fun. And that's pretty much it. I didn't want to show this because I think it's funny, and it wouldn't. My profile photo is Pepper.
That's awesome.
Yeah, so that's pretty much it.